Hello, everybody. We are going to be working on the Chapter 10 exercises tonight. And the first one we need to tackle is exercise number 1. Keep in mind that this chapter is about inheritance in Java programming. So the exercise reads like this. It says, create a class named horse that contains data fields for name, color, and birth year. Include get and set methods for these fields. Next, create a subclass named racehorse, which contains an additional field that holds the number of races in which the horses has completed and additional methods to get and set the new field. Write an application that demonstrates using the objects of each class and save the files as listed here, horse, racehorse, and demo horses. We will begin by building the horse file, but I'm going to jump over to Eclipse here and begin by first creating a project node. So I'm going to just come up here and say new Java project. We will call this one Chapter 10. All right, so now we have our project node here. And let's go ahead and right-click the source folder and create a new class file. All right, this one's going to be called horse. This is the master class file, or the blueprint that we'll use to build all of our horses. And we will go ahead and click finish. We do not need a public static void main here because this will be non-executing. It simply creates the blueprint for the class. Now, we were told to create private variables for the name, the color of the horse, and the birth year. And so I'm going to begin by doing that. So I'm just going to come up here to the top and I'm going to create a series of private variables. The first one will be a string. Makes sense for a name. So let's just call that one name. Let's create another private variable, once again, another string that will hold the color of the horse. And then finally, a private variable that will hold an integer, which will hold the birth year. And I will name it like so. None of these are preset. Now we will want to have getters and setters for all of these. And yes, you can manually type all this stuff in, but I'm a huge fan of saving time here. So let's just go ahead and do a quick right click and we'll go to the source menu in Eclipse and we'll generate getters and setters. And you guys might be getting used to this interface by now. And those of you that are still coding manually, maybe using more primitive tools, this is one of the reasons you want to stop using those tools. You know, if I can keep encouraging you to do that. And we just want to very simply check all of these. And of course, you can always expand it and just make sure that get and set is set for each one of those. And we're going to go ahead and just click OK. Now that will automatically generate these. And in truth be told, if you're writing these manually, and some of you will, you might not write them exactly the same way, but they can function the same way even if the code is not exact. The point of it is once those variables are assigned to an object that we're going to instantiate, right, all that terminology, we have the ability to change the horse's name or see the horse's name, change the birth year or see the birth year, change the color or see the color. You know, that's the get and the set for each one of those variables. All right, so that's all our work here. There's no yellow or red flags or highlights here, so we know our code's okay. This is non-executing. If I hit the run button, nothing's going to happen. It will compile it and turn it into executable code, but there's no actual executing of code here. This is just a class file. So I'm just going to do a Control S here to save this one. As I move to the second piece here, I do want to go back to my instructions just really quick to kind of keep things straight. So it says next, create a subclass named racehorse, which contains an additional field that holds the number of races in which the horse has completed and additional methods to get and set that new field. All right, so let's take a look at what that looks like. And this is going to be actually a very short amount of code. There's not a lot of code in this. But it really does show the concept pretty well, which is why I think it's very useful. Let's come back over here to the project node on the left side of the screen, and I'm just going to right click and once again create a new class file. All right, this one we're going to call racehorse. And normally I might do a couple of additional settings here, but I really want to kind of do this manually, so I'm not going to make the settings in this spot. We don't need the public static void main again. This is once again a blueprint file. So just naming it racehorse will be adequate. All right, so here's the base part of our program. Now, because this is going to be, and how did the book say this, a subclass, is how they're referring to it, which means that horse is going to become our superclass, or the the blueprint that we're extending. So we're going to grab everything that horse has to offer, so the name, the color, and the birth year of the horse, and we're going to include that in the capabilities of racehorse. So the way that we do that is by very simply adding to the class statement at the top, and we're going to say extends horse. And that very simple terminology, as long as these, mind you, once again, are in the same folder, and that's where we're putting them, by just adding extends and horse, I now have all the capabilities listed here included in racehorse automatically. So racehorse, even if I do nothing here, has name, color, and birth year with getters and setters already attached, right? But we're going to add some capabilities to it. So the first capability that we're going to add is by putting in a private variable that's going to, and I'm going to choose to make this an int, which is going to indicate the number of races that the horse won or participated in. And that's the only variable. Now, think about it, right? A regular horse doesn't necessarily run races, but a racehorse does. And a racehorse is a type of horse. So this is kind of the inheritance concept. So a racehorse, in principle, will inherit name, color, and birth year, name, color, and birth year from the horse class, but adds to it another capability that regular horses don't have, which is how many races have you run? Only racehorses have run races. So that really, in a nutshell, is the principle of inheritance, right? So I'm creating this class now, and it will also need getters and setters. So I will do that right click again, choose the source menu, generate getters and setters, and yes, we'll make sure that all of these will get it. We'll just allow Eclipse to do the work for us. And now we have the getters and setters for the races data field. And that's it for the subclass, folks. That's the whole thing. All right. I think we should take a pause here for just a moment. And let's do a 5-minute break. I know this is a little bit early in the class to do it, but I have a couple things I need to tend to, and I'll be right back. So 5-minute break. See you at 8:32. All right, we are back from break, and now we are going to work on the next piece, which is to demonstrate that this works, okay? And the way that we'll do that is we're going to build a new program called Demo Horses to show that it works. So let's go ahead and right-click and create another new class file. And we're going to call it Demo Horses. This one will have a public static void main because it will be an executing program. It will actually run the code. And so we'll check that box and click Finish. So now we have the beginning of our Java program here. I'm just zooming in just a little bit so you can see it a little more clearly. And we will need to go ahead and instantiate some horses. And to prove the capabilities, I think it's probably wise to create at least one of each. And that's what I plan to do here. So I'm going to create one regular horse, and then I'm going to create one race horse, and then I'm going to play with the settings and then make sure it works. So this is nothing more, folks. We're not doing any like programming logic here or anything. All we're testing is the capability of extending one class into another, or having a superclass and a subclass where the subclass pulls capabilities from the superclass with it. All right, so let's go ahead and create a horse. So we have a horse object or class file, and so I'm calling that in as a library, horse. And let's name our first horse, horse 1. That's probably a good name. And here we will instantiate, we'll call on the constructor function, the default constructor, which is just horse. And so this will create a horse with, once again, the name, the color, and the birth year. None of it is preset. We're going to set that later, but here it's being created. Next, we'll go ahead and create a racehorse. So I'm calling that class in directly, and this one will be horse 2. And this one will also be in U1, and we will call once again upon default constructor, and which is racehorse. All right, so now that we've created those 2 horses, let's go ahead and start giving them some values. So let's start with horse 1. So I'm going to say horse 1. Let's go ahead and set the name. Now, what I love about this, and you know that the technology is working, is that as I was typing that set command, so I typed horse 1 dot, Eclipse recognizes that this is an object in the same folder and pulls back all the different things that I can add to it that come directly from horse. So if you look at this list here, horse, 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 right? So all the sets and the gets are listed here, and I can call them directly because this is actually going out, this little dialog box is going out to that other file and reading its capabilities and bringing them back in and putting it into the box for me. So it shows that the files are connected right there. So we know that it's basically working. And in this case, we are going to set the name for the horse. And so we'll find the set name command here and put it in. All right, so let's come up with a name for the horse. How about Old Paint or something like that? That sounds like a good horse name from like a Western. And I can see that I do have an extra paren and semicolon here at the end. That's not good, by the way. So the first horse, regular horse, is going to be called Old Paint. Let's set the horse color. So we'll go horse 1 dot set color this time. And you know what? I'll just type in, I don't know, brown. That's a pretty common horse color, I think. And let's give it a birth year. So horse 1 set birth year, and I'll make it 2015. I'm not sure how long horses live, but I know that a lot of the ones that race are usually pretty young. That makes sense. And I don't know if horses live 10 years, 20 years. Does anybody know what the lifespan of a horse is? I'm really curious. I'm just going to say mine's about 6, 7 years old here. So I'm going to put in 2015 as an integer for horse 1. Now,
a quick Google search says 25 to 30 years for how long a horse lives.
Well, isn't that, okay, very, very interesting, and thank you, Laren. All right, now let's set all the same things for horse 2, and in fact, I'm going to save myself a bunch of typing. I'm just going to copy these 3 lines, because they're basically going to be the same-ish, right? First of all the 1s will change to 2s, because now we're going to do this to the race horse, and now we'll just change the values. And so the name for our racehorse maybe is, I don't know, Champion. Hopefully, right? And maybe this horse is, I don't know, black instead of brown. And this one's probably younger if it's racing, so maybe it was born in 2019. Might be a 2-year-old or a 3-year-old. All right, 2018. Now, remember, horse 2 has one extra capability, though, which is the number of races. So I'm going to add one more line, horse 2, and then I'm going to set the races and see how this one has that extra capability that the others did not, because it is of type racehorse, which pulls from regular horse but adds one more capability. So this is the example of the inheritance, folks. So we are going to set the races, and let's say this horse has run 5 races. All right. Now to prove that it worked. And the way that we're going to prove this is we're going to output the information. And so I'm going to write a series of statements here. So the first one is going to look like this. And yes, I'm copy and pasting these in just to save time. And more importantly, it's accuracy as well, so I don't mistype. So the first one, we're going to output first from horse one, the name. So we're going to call on horse one and get its name. So it's going to say old paint is, and then we're going to get the color, brown, and was born in 2015. That's what it should say. And notice it, in this case, instead of setting the values, we're getting them. All right. Let's do the same thing for the second horse. So that's also going to be really close to this. And as I paste that in, now we have horse two, same exact parameters, because horse two has all those same features, right? The name, the color, and the birth year. What horse two has that's different, though, is the fact that it's run races. So I will write one more output statement to pull back the value for the races to make sure that it got there and it's stuck. And in this case, we're just going to say that horse two, we're going to get its name again, has been in, we'll pull back the number of races and then say races. So horse two has been, in this case, 5 races. All right, I'm going to go ahead and run this. This is going to be a pretty simple one, really. But it's the concept of inheritance that's really important here, folks, and I just want you to keep that in mind. Let's just pull the console up a little bit, and let's go ahead and run. Oh, okay, and of course, it runs the wrong program. Let's go ahead and save this one. And now let's make sure this tab is active and go ahead and run demo horses. All right, so there it is. Old paint is brown and was born in 2015. Champion is black and was born in 2018. Champion has been in 5 races. And is that the correct information? Absolutely. Now, if you want to test this further, what you can easily do, and normally I would kind of recommend this. This is a very simple example, but if you have subclasses and superclasses that have significantly more data fields, then you would want to test all the data fields, the ability to write to them and retrieve from them. And then for anything that's a subclass like racehorse, to feed in multiple different values for each one of the data fields that are attributed only to the subclass. But a subclass is a really powerful way to still create objects while making them unique from the superclass that they're being inherited from. The terminology on this, I'm going to tell you what, you guys, is pretty weird because people will say everything for superclass to subclass. Some people will say parent and child. Some people will say inherited or extended class. But that capability is generally called inheritance, where we're inheriting the capabilities of one class structure into another, and then ramping that one up to make it unique somehow from the class it's borrowing from, yet it still has all the capabilities of the parent or superclass. And if you think about it, the parent-child approach, the inheritance, it's the racehorse is inheriting all the features from the regular horse. It just has one extra feature, which is the number of races that it's won. All right. Any questions on this one or any problems? It looks like everybody's okay with this exercise, so we are going to move forward, folks. And let's jump back over to the book and read the next exercise. The first thing I want to do is I want to make sure that we're looking at exercise 5. I just want to verify before I start digging in here. This one's got a little bit longer description, but the same kind of approach, a superclass, a subclass, and then an executable file to demonstrate it. All right, let's read this. It says, exercise 5 says, the developers of a free online game named Sugar Smash have asked you to develop a class named Sugar Smash Player that holds data about a single player. The class contains the fields, the player's integer ID number, string screen name, and an array of integers that stores the highest score achieved in each of the 10 game levels. Include get and set methods for each field. The get and set methods for the scored should each require two parameters, one that represents the score achieved and one that represents the game level to be retrieved or assigned. Display an error message if the user attempts to assign or retrieve a score from a level that is out of range for the array of scores. Additionally, no level except the first one should be set unless the user has earned at least 100 points at each previous level. If a user tries to score for a level that is not yet available, issue an error message. All right, then create a class named Premium Sugar Smash Player that descends from Sugar Smash Player. Well, very twisted to say, at least for me. This class is instantiated when a user pays an extra $2.99 to have access to 40 additional levels of play. As in the free version of the game, the user cannot set a score for a level unless the user has earned at least 100 points on all previous levels. Create a program that instantiates several objects of each type and demonstrates the methods. Now, for as weird as this sounds, this is not how you make a video game. I'm going to tell you what, folks, no, this is exactly how you make a video game, because we're really only looking at one aspect of it. What we're looking for are the scores for each player and maintaining it, and then how we give them access to the subsequent levels in the program, whether it's free access or premium access. And as a programmer, you often might be given tasks just like this. You might not be given the whole program to write. They'll just say, hey, can you write a class that does this for me? And you know what? Just make sure the ID number is an integer, right? That's why they say integer here. And make sure the screen name's a string and that the scores are an array of integers, and that's the kind of information the programmers will share with each other, because that really should be enough to generate this piece and then have it work with any other part of the game. All right, so let's begin then by creating the master or superclass file, Sugar Smash Player. Let's start there. Let's jump over to Eclipse. We're still going to be working inside the Chapter 10 project, and I'm going to right-click here and go ahead and create a new class file. We are going to call this Sugar Smash Player. Sugar Smash Player. That's correct, isn't it? Yes. Okay. Just want to make sure. And we don't need a public static void main, because this is going to basically be our blueprint. Struggling for the words there. Sorry. All right. So now let's go ahead and move on to the next piece of this, which is to get that going. So we were given very specific information in terms of what fields to include, and that's pretty simple. So let's go ahead and put those in straight away. So right up here at the top, we're going to create a series of private variables, with the first one being the ID number, and we were already told that should be an integer, so pizza cake. And let's just go ahead and call that ID number, just like that. Not pre-assigned, we're just creating the variable structure. The other thing that we were also given was a private that will hold a string that will be the player's screen name. Right? And then finally, we're going to be creating another one that is going to hold the structure of an array of integers that's going to hold the scores for the game. And in this case, I'm looking at the author solution, and the author did something kind of interesting, which was the integer array that's going to hold those is protected. Does anybody here know what that access modifier does here in Java when I say protected?
Is that locking the data type?
It is. It is locking it so it cannot be manipulated. Is exactly what it's doing. Now, I can argue that we may not need that here really for what we're doing. However, you don't want somebody to have, like, think about this, right? If somebody was really crafty and could run your game and was a clever programmer and can somehow get into your source code, would you want them to have the ability to rewrite their scores so like maybe they could get the premium access without having it, right? And so one of the reasons we do that is to, protect access to the data so people can't manipulate it and kind of cheat, basically, is really what this is. Um, so, I mean, we could write it as just a standard private, but in this case, we're protecting it, so it's in a way sort of unalterable. Another thing that I think about as I'm doing this, and you know, I see that the author thought about it too, is okay. So we have these things, and we have to get and set methods for each field, and the ones for the score should require 2 parameters, et cetera, et cetera. But the other thing is that they're also looking for this like minimum score level of at least like 100 points on all the previous levels before all the subsequent ones are unlocked. And to me, it makes a lot of sense rather than hard coding that number of 100, because obviously we're going to use it a few times. Let's create a variable, or excuse me, a constant for the program that just holds that value that will be attached to the object. So I'm going to come in here and type in a private final int called min score and set that equal to 100. It's a hard-coded value, and anywhere in the program where I want to check against that 100, I'm going to drop in min score to accommodate that 100. Remember, once again, the advantage of doing it this way is if you decide to change it to 150 or 90 or 120 or something, you just come here, change one number, the whole program changes. The other thing that would be helpful is the levels that you're dealing with. And frankly, I'm going to preset that too. And we're working with 10 levels. I'm going to create another private variable here, which is an integer, and I'm using all caps. I guess I don't technically have to use all caps, but I'm just thinking, and it might be helpful just from the standpoint of if I'm moving data around just to differentiate it. So I'm going to choose to do that just for my own sake, not that it's necessary. All right, so the levels that are available, 10. All right, so now we have to do some other work. First, we do need to do getters and setters for everything. And so let's go ahead and make that happen. That's pretty simple. And do they say getters and setters for everything? I want to just see this here. Include get and set methods for each field. And I think they're referring to at least these 3 things. So I'm just gonna use the automatic tool here to generate these. So I'm just gonna come down here, do the right click, choose the source menu, and do the generate getters and setters. All right, we definitely want it for ID number. Definitely want it for name. Definitely want it for scores. Do we need it for levels? No, because I'm using that more for reference, and we need it for the minimum score. You know what? For the minimum score, we probably want to at least get the minimum score. And I want you to notice, and this is why I'm doing this exactly, is with the name, the scores, and the ID number, we can get and set them. So in other words, if a player chooses to change their screen name, they can do it. They can see their screen name and change it. Will the score need to be set and changed? Absolutely, because as they earn more points, they're going to get and set the score. The ID number can also be set and changed. Now, interestingly, because I set the minimum score field to a constant, right? It's got the final thing in there. There's no way to set it. It's preset. Your only option here is get. Isn't that kind of cool? So you can get the minimum score, but you can't set it. Not allowed. Levels also, and I'm thinking here more and more. Maybe the levels thing needs to be hard coded as well. So I'm actually going to cancel out of here. Maybe this does need to be a final, because that is kind of a given in the game too. And I don't know if you guys agree with this logic or not, and you might argue this logic. But once again, I'm going to set that to a final, and then I'm going to come back here and do that pattern one more time. So getters and setters, and we already agreed ID number, name, and scores for sure. And I'll just expand them so you can see them all. We already decided that for min score, we're just going to get it. And now for levels, we can also just get it. We can't set it. And that's really how I want this set up. Okay. So I'm going to go ahead and just do that, generate all those. So here is the code for those. And, you know, for those of you like rapidly like screen copying what I'm doing here, kind of give you a hint. One thing you can do is you can screenshot my screen, use your snipping tool, and grab the code and save it as a file and look at it later if you're kind of hurrying to catch up. The one thing that I think perplexes people a little bit, because we haven't done this yet, is we are working with an array structure here. And so we can actually, you know, send in and return, you know, the individual portions of that array. We're not really defining the size or shape of this. Notice it's going to kind of dynamically generate. Now, there's some additional pieces to this which make it a little bit more complicated than the horse exercise, and that is some of the stuff that was listed in the details here. So I'm going to go back and read these and point out the parts that are important. Okay, the get and set methods for each score require two parameters, one that represents the score achieved and one that represents the game level to be retrieved or assigned. Okay, that's pretty simple. Next, it says display an error message if the user attempts to assign or retrieve a score from a level that is out of the range for the array of scores. Additionally, no level except the first one should be set unless the user has earned at least 100 points at each previous level. And if a user tries to score for a level that is not yet available, issue an error message. And all right, and that's all in the first file. So we still have to get we have to basically get those pieces into this class file. So in other words, we have to write some custom methods here to make that happen. There's no other way to do it, to build it into the structure. So here's how I'm going to do that. The first thing that I'm going to do is what I read in there is there has to be a way to both, you know, not only set the score and get the score, but relative to that score, we need to do some work. So I really don't need to necessarily create brand new methods here to do the work. What I need to do is leverage, you know, how do I say this? I need to leverage what I have already to run the logic to keep stuff from happening or happening depending on how it's working. So first things first, in order for us to have the array structure to work with, to store the scores into, we have to create that. And what I'm going to do that is I'm going to create a constructor function up here, and this will be public now, so we can call it externally, and we will call it sugar smash player, which is just like our class name, followed by a set of parens and a set of curly brackets. Inside there, all we're going to say is that the scores, remembering this is a whole array structure now, not just one score, is going to be a new integer array with how many positions? Well, initially we allow up to 10 levels for the free, right? So we will just populate inside here levels. And we are going to spell it correctly though. And so really we're saying an array with 10 positions. All right, so that's going to happen. So when we construct the object, we are giving them 10 levels for free. There it is. And therefore, the scoring mechanism for storing that is now available. All right. Now, at some point, we are going to need to both set the scores and return the scores. And let's think about first, and I'm thinking that getting the scores is probably easier to write than setting the scores. So let's go to the get score method. Once again, notice how we're dealing with an array here. So that syntax comes into play, because we will be dealing with array positions, although we won't necessarily get super deep into this. And I'm keep thinking to myself, do I really need to worry about um, returning the entire array here? And this is what I'm thinking about. And my brain is telling me, well, yeah, that would be helpful, but I might only be looking at one individual score. So the thinking is, and this might break your train of thought a little bit, is I'm going to eliminate the array aspect of this, and I'm just going to return an integer, because if I'm returning a score, I'm returning just an integer, not the whole array. I just want the one score. So I'm going to be changing that here, but that also means that in order to retrieve that score, I have to feed it the level number that we're on in order to get it. And so that's where I get kind of that other dimension from. So here I will call upon the level. All right. Now that we have that in place, we will now do a little bit of logic. So now we start to think about it. Now we will check to see if the score falls into our range. So what I'm going to do first is I'm going to kind of preset a score to a value that forces it to not reach where we're going. So here, I will do this. I will actually declare a localized variable here called score and set it to -99, because I know for sure that's not going to reach that value. And then I'm going to run some logic. I'm going to say if the level that we're currently on, my thinking here, is less than 0, or that level is greater than whatever our array structure length is -1, because that's the index position of it, then we can go ahead and do something which is basically indicate that, and think about this scenario here. So, and I'm missing my, there we go. So if the level is less than 0, which hopefully can't be, or the level is greater than the number of scores available in the array, we can pretty safely say that this is not even valid. And so we want to just put an error message that says something like this. And I'm just going to say is an invalid level number. So if there's not a valid level number in there, we don't want to allow it to happen. Okay, so that's one thing. So that's a little bit of error checking there. And if it's not the case, right? So we have an else situation. Then what do we do? Well, then in that case, we grab the score. And what score are we grabbing? The score from the last position. And here's where we will take the level that we're currently on, and it's the lowercase version of it. This is my strategy, by the way, so I can keep it straight. We're going to grab the score from that position, because that's the one that we actually want. And then we are not going to return the whole array of scores. We are just going to return this variable which we just set, right? And it should be the case that there is a level, and that level is not beyond the array. You know, it's in, and basically what this first part of this does is it makes sure that we're in the array. And then if we are, let's pull that score out and return just the score. And so because I'm really not working with the array anymore, I'm also going to alter the name here, and I'm just going to call it get score. I really don't want to pollute the waters with the other object, because I'm not really going to be getting and setting the entire array. I have no functional need to do that. And thus, I don't need this, you know, and so I would, if I was writing the code, I would probably comment that out. No harm done in it being there, so I'm going to leave it. but frankly, not necessary. All right. Now, the other piece of logic that we're trying to solve is all this stuff about the score, which level we're on, and then checking to see if it's is it a bad level, for example. And so what I think I'm going to do next here is in set scores, because I really kind of need to be able to set the score. But if I'm setting the score, I want to make sure that I'm doing it correctly so that I can open things up to let the next thing happen. So now that I have this thing highlighted, this might be a good, like, close enough name, because if I'm going to get score singular, I might want to set score singular too. So I'm going to come here and kind of make the same kind of tweaks that I just did in the other one. So I'm going to get rid of the S to start with, and then I'm going to come inside here. I mean, I can't pass in arrays anymore because that's not what we're dealing with, but we will be dealing with both the score and the level, but we're dealing with those things as kind of like individual items. So I'm going to change the plurality of it just for my own sake. And I'm going to feed in the score and the level as integers for checking to make sure, is this level bad or not? And if it's not, then go ahead and make it store the score in here. So the first one will return the score. The second one will set it. Now we will need to change the code inside here too. So I'm going to get rid of this, and I'm going to start with a blank slate once again. But I'm going to start with a couple of things. First, I'm going to set a Boolean variable that basically does this. I'm going to call it is bad level. So are we checking to see is this level bad or not? And we're going to preset it to false, assuming that it's true, if you see what I mean. And we got to put an equal sign here to do the assignment. Another thing that might be helpful is having a generic integer variable to kind of help us keep count and track of things. So right above this, I'm just going to create a really quick little integer named x. I don't need to preset it. I'll preset it in other places. Right. Now we need to do some logic. So the first thing that I'm thinking about is if we have a level, once again, that is out of range and it's not valid, we can actually copy the syntax that we have here to get ourselves started. So I'm going to do that. I'm going to just bring that verbatim down here. So if the level happens to be less than 0, not allowed. Or if the level happens to be bigger than the length of the array, which means that it's above the array position that we're in or above the level we're on, there's obviously a problem. So we are just then going to directly just do an output statement telling people that it's problematic, like so. And so the output would be, whatever level number it is an invalid level number. And we'll test this, by the way. If it happens to be a valid level number, well, then different situation. Now we have a whole different set of logic to deal with. And in that case, we want to start stepping through the array of scores and checking to see that if the scores in the array, every position in the array, so a score for each level, if that happens to be less than that 100 or the minimum score, then that is bad level will be flipped to true. If you see where we're going. But that has to be put inside of a loop because we have to check multiple positions. So we're going to write the loop first. Here we go. For, and I suppose I could have initialized x right here, but here it is. For x equals 0, while basically x is less than the level that we're sending in. So whatever level we're sending in, we'll increment by 1 each time. In that scenario, we will loop, and then for each iteration of the loop, we will check to see if the scores, right, so now we're looking at the array, in the current position happens to be less than, and see I'm talking myself through this as I type it, than the minimum score that we predetermined, which was 100, that scenario hits, then is bad level gets set to true. Okay. Now, it has to go through each one of the scores to check it. Now, once that's done, now we can move on to the next piece of logic. And that is, if it flips to true, then we can say that, so in other words, they didn't get 100 on all the levels. Now we can give them an error message. So I can just write a simple if and say if is bad level, which also reads as if is bad level is true, right? Which is all we're checking. Then we're just going to do a simple system out print line, and I have one all set to go here that I'm just going to drop in. And what I did last time was this. Score cannot yet be set for level because you have not reached it yet. So you didn't hit all hundreds, right? So if it's a bad level is true, you're not going to be able to proceed. Else, if you can, right? If is bad level never gets flipped to true, meaning you got 100 at least on everything, then scores, the array, and whatever level position you're currently in will receive that new score. Now this combination of logic on these two methods that were slightly altered, right? So we did not use the array versions of this. We singularized them and only dealt with the data, is really what I did. This is the logic that helps to achieve those couple of sentences that we had before relative to the superclass. Okay, so the superclass for this particular exercise, folks, is here. And I'm going to highlight this, copy it, and I'm pasting it into CodeShare just to accelerate workflow here, if you guys don't mind. So everything that's in CodeShare right now is going away, by the way. And there is the class file with the methods. And the reason I'm doing this is there's enough nuance here where I don't want to sit here for a half hour and wait for everybody to catch up typing. It just makes more sense to do it like this. I'm just sharing it with you. And I hope you guys appreciate that. So there's the code. If you guys want the CodeShare link, and I know I'm just waiting for the question, here's the CodeShare link. You can go right there and grab it. It's in the chat window. Just remember, if you highlight to copy, to unhighlight when you're done. All right, let's move on to the next piece now. And let's go back to the exercise description once again to read the next piece. Next, create a class named Premium Sugar Smash Player that descends from Sugar Smash Player. So we'll extend that one. This one is instantiated when a player pays $2.99 to have access to 40 additional levels of play. As in the free version of the game, the user cannot set a score for a level unless the user has earned at least 100 points at all previous levels. So a lot of the logic should follow. And then we do all our instantiation. So now we need to create that additional class file. And so that's what I'm going to do. I'm going to come back up here to the source folder and select new and create new class. Now, as I do this, I want to make sure that I name it correctly, and I think they're calling it Premium. Okay, so let's type that in. Premium Sugar Smash Player. This one, once again, will not have a public static void main. Let's just go ahead and pull that in. We know that this will extend, and we say that in plural, and it will extend Sugar Smash Player. So we have all the capabilities that we created here are now included inside of our subclass or child class or inherited class, all those different terminologies. All right, next thing we have to do is we have to think about what makes the premium different from the standard. And so if you start doing some math on this, the minimum score part of it isn't going to change. However, in some ways, it kind of makes sense to maybe still include that here. And I'm thinking to myself, is that really completely necessary? So I'm having this little debate in my head because it follows, right? It follows from one class to the other. Yeah, and you know what? And then I'm thinking to myself, the other reason we made this protected as I look at this, remember I did getters and setters? Well, getters and setters won't work on something that's protected anyhow, um, uh, which is another reason why we changed it. But here we already have that private final int minimum score of 100 preset. I have this temptation to add this to the premium as well, but I don't think it's necessary at all. So what we're going to do now is instead, we're going to take a look at this other piece, which is the levels. Now, really, it's the same piece, right? It's the same component, but in this case, it's going to have a different value, right? So it exists in the superclass, but now we're creating a subclass with the same thing. And they say, like, if you pay, you get an additional 40 layers, which really changes this value to 50, right? And so what I'm going to do is I'm actually going to copy this whole line, bring it over to the subclass, and I'm going to paste it in. And I'm going to come in here and I'm going to change this to 50. Now, red flags should fly all over the place for you guys. And the first thing is, why was I like waffling on this whole, should it be a constant or should it not? And the answer for that is, if I'm going to bring this in here and change it to a different value, but in the superclass it's already a constant, guess what? I can't change it. Right? That's kind of problematic. So I really do have to come in here and remove, not from the subclass, but from the superclass, this little piece here. This is why we are removing that. Now that I'm thinking about it, I should probably do the same in the subclass. So make sure you save that change, by the way, if you change it. So we don't really need it to be a final. We're just kind of treating it like one, like we do in Python. We pretend it's constant, but really it can change. All right, so that's going to be an important piece. The other piece, once again, going back to that minimum score thing, I think we're going to be okay because that's not going to need to change here. I'm just looking at the example that I have here. And for some reason, in my example last time I did this, I did make it what I did, let me just show you what I did. I did this. I had this in here as a private variable set to a final, but then if it's inheriting from here, I don't need to do that, and so I'm not sure why I did that. Maybe I was trying to solve a problem or just forgot. I'm thinking it's probably just forgot. All right, so now that we have that in place, so this is what makes it different. Is this the premium player gets 50 levels, the regular players don't. We also need, with the premium player, to also instantiate things just like we did with the other, the super class. So we can kind of actually copy this constructor function as is, bring it over here and add it to the subclass. Of course, we do have to change the name so it matches. So it's got to say premium sugar smash player. And we will, once again, instantiate a new scores. Now, notice scores is not listed here as a private variable. It's being inherited from sugar smash. But we are setting that array so it now has 50 positions instead of 10. So that's the premium player. The other thing that we're going to throw in here is the ability to return the number of levels, because we will need to know how many there are available so that we can do some other tasks, right? Here, we're just going to create a very simple method. Yeah, I'm typing it out manually, where we're just going to get the levels. It's going to be simple enough to just type it. So get our curlies in there, and all we're going to return here is where the levels are set. That's all we're doing. And this is just a mechanism to be able to see that it's been set to 50. Another thing that the author recommends really strongly here is to do an override. And I don't know if you guys haven't really learned about the override concept quite yet, but the principle is basically that we are allowing things to function in a state that normally they wouldn't function in, and we're not allowing this to be the primary thing. It's allowing kind of like a rudimentary extra control. I do notice that this is flagging. Yeah, and see what it wants me to do is have the same method inside of, yeah, and actually it's telling me to remove the override. Let's just do that because that'll probably work better. All right, so let's follow the suggestion, and I think this will work. And so what this is really doing is it's returning levels, and I think why I have the override in there. I'm trying to like find a better way to phrase this, folks. Sometimes you have to search for the words, and we want to make sure that it's returning the levels from here, which just reset it, and not from the original class. Let's go with this and see if it works. And so this is really the completion of the second piece. So this is the superclass that we did before that I already pasted into the code share. And now here is the subclass so far. Right? And actually this is all of it. So I'm going to go ahead and copy this. This is going into code share also. I'm going to be putting this at the bottom of the code share though, so you guys still have access to it. And what I'm going to do to make sure that you don't confuse them is I'm going to put it below the bottom line there. And it looks like I'm having problems with the internet connection. And can you guys still hear me?
Yeah, you're still here for me.
Yep.
Okay. And it looks like code shares is the one that's choking here. Okay. I was getting a little worried there. All right. So down here, I'm pasting the subclass definition. All right. Last piece now, we need to create the file that's going to test all this. So let's go ahead and right click, create a new class file once again. This one will execute, and they do want us to call it, where is my book? They want us to call it Demo Sugar Smash. All right, so let's go back to Eclipse and name it that. Demo Sugar Smash. All right, let's go ahead and click Finish. We do have the public static void main there, so our program will execute. And now to get that last part built. All right, so this gets a little bit lengthy, and what I'm going to do here, and I'm trying to be mindful of time, and I know we don't have a lot, is I'm going to put up on screen very systematically here, because I have created this kind of in segments, borrowing really heavily, by the way, from the author. And we are going to put on the screen the instantiation and settings for a couple of different players, each individually, manipulating all the different possibilities to make sure that the logic is working. And you'll see what I mean here. So I'm taking this one piece at a time, so please bear with me as I do it. The first piece, and I'm doing this via a copy paste, by the way, and I'm thinking here's a cleverer way to work, because I am going to allow you guys to kind of copy from me. All right, and I'm doing this kind of with the very firm mindset that we have limited time and not a lot of time to work on homework, but the concepts that we're learning here are important. So it's not that I'm doing your work for you, it's about the concepts you're learning. So please take that to heart. So I'm going to do the coding here at the bottom of the code share, and build it here, and then move it over to Eclipse to see how it works. And that way, as I'm working on it, you guys can come in and start grabbing the code as I'm doing it live. So the first line I'm going to put into my program. So all of this is going to go in public static void main. Oops, not that. All right. And in fact, here, let's get the first part of the program in there too. I'm grabbing this from my other screen. So there's the demo part. And I'm going to go ahead now And let's close the curly brackets just to make the highlighting correct. And let's make sure we're color coding for the right language here. We are not. Holy cow, no wonder it doesn't look good. Much better, much better. Now it looks like Java. All right, so here in public static void main, I'm going to begin by instantiating a Sugar Smash player. So I'm just a regular Sugar Smash player, not a premium. And I'm going to call him SS player. And see, I call the constructor, and that automatically creates them and gives them 10 levels. We are going to then, trying to get my indents here. We're then going to set an ID number and a player name. So I'm going to do that like so. The player I just created, SS player, set ID number and set name. Next, I'm going to go ahead and just put in a little message on the screen. And what I'm saying here is simply some text that we can look at start, and then we will try to get some stuff on the screen. But now I'm thinking to myself, okay, what am I going to put on the screen? All right, so this is the conundrum of a programmer, by the way. And how am I going to put it on the screen? And holy cow, if I'm putting stuff on the screen, it's probably going to be the same stuff over and over and over again. So instead of rewriting all those statements every time, how about this? Why don't I write a method inside my program here that will do that for me? And then all I have to say is display the player, and it just does it, right? So I'm now going to write one additional method to add to my program. So I'm coming down here, and I think I might go with this like new indent that it's suggesting. So I'm going to say public static void, and in this method we will just call it display. Its only job is to put stuff on the screen. What are we sending to it? We're sending in a player object. So we're going to send in a Sugar Smash player. And we'll just use, I don't know, P for player. That will be the variable name we use inside here to represent it. I'm kind of used to Eclipse, as you can tell. This is enclosing my curly brackets automatically. I feel lost, right? So we want to get stuff on the screen. And here's a very quick little routine, folks, for getting that stuff on the screen. And I want you to notice there's a system out print line here, and no, it does not have to be on separate lines like this. And what we're going to do is we're going to pull back the person's ID number and their name. And then we're going to set up a loop that's going to loop through and go through the score array and pull back the score for each level and display it. And then it's going to print a blank line for us and call it a day. And so this is something I'm going to do for each of the players I have. Why rewrite this code every time? Let's just do it once and we'll call it. Okay, so you see that logic. So you can take that whole method and borrow it. Now I'm going to jump back up to where I was, and I'm going to continue with my logic. And what I'm going to do is I'm going to show that the first player at the start, if you think about this, I will now display that player. So I will look at his name, ID, and the scores, whatever score he has. So at the start, it'll show me what it does. Then we want to go in and start changing some of the values for this. So for example, I will take a player and set his score. And as we set a score, we're going to be setting both the score and the level. And just to see that it works, this is kind of the cumbersome part of this, frankly, is we're going to put in another message after setting the first score. And then we're going to look at, well, then we're just going to copy this line. We're just going to display that player. Okay. All right. And then what we'll do is we'll start going through this logic of setting each of the levels incorrectly to see what happens, to set it correctly to see what happens, and then to show it. And so I'm going to do that with a series of commands. So first I'm going to do one, or I can't really display the next score technically, right? Because I'm going to position 4, which is the last position, well, not the last position, but the 5th position in the array. And I'm trying to put in a score, but I haven't set them for positions 0. Well, I did for 0, but not for 1 or 2, right? And so this one here is incorrect. We're doing it on purpose, and I'm saying that. And then this one is correct because it's going to the next level, and then we're taking a look, all right? Then let's go ahead and try to go to the 3rd position. And I know this is kind of complicated because there's a lot of logic here in the mix. In this case, now we can go to this position. We can put in a score of 100, right, which is an adequate score. But then ultimately, we'll go through this process, and I'm just pasting them all in because I'm just looking at the clock going, oh my God, the day is almost over, where we will then subsequently put in scores that are correct. So for each one of the levels, they have to get up to 100 points. Otherwise, it messes you up, basically. And then we'll take a look. And then finally, we'll kind of jump over the scores that we have and try to go right to the last position in the array and see what happens. And so for right now, I think what would be good to do so far is just take the code that we have, and I'm going to take all of this, I'm going to bring it over to Eclipse and try to run it and see what happens. And I'm thinking here, I don't think we need any additional libraries or anything. Well, let's, yeah, be careful what you copy here, folks. And after you highlight something to copy, if you could be kind enough to click off and unselect, because it helps people with their selections. And don't select the whole page. We only want this part. So I'm going to copy that and bring it over to Eclipse. All right. So now I'm basically going to replace all my code here because that's what I copied and pasted in. Thankfully, I only see one red underline here. That's pretty darn good for typing outside the IDE and bringing it back. So let's see what that error message indicates here. It says get levels.
Oh, okay.
Oh yeah, and I think I see the problem here.
I think in the demo Sugar Smash program when you were having your error, I think it's because when you set the private in your constructor, the levels was in all caps, and here it's not.
Oh, looks right. Oh, but this is the premium. Uh-huh. Yes, it is. Correct. Very much correct. All right, so let's fix that. Let's come back here. Not what I wanted to do. Yes, that's right. That's all caps. Now the other fix could be, I could just fix it here. This might be actually easier, but let's do it here. And you know, it's interesting that the automatic fix it up, right? So let's just go with it. All right. Let's try running what we have so far and see what happens. This is the standard player version. Let's see what the output looks like and see if all the stuff we're feeding in makes sense. All right, so I'm going to pull my console up here. In fact, I'm actually going to pull the console off to the side here and run it in my sidebar. I don't know if you guys know that or not, that you can do that, because I think this might be a little bit better view for us. So let's go ahead, make sure that the demo program is saved, and let's go ahead and execute. All right, and so I want you to look at the output. So we set the name, and all the scores are blank. Then after we set the first score, you can see the first score is set. Then we try to set the 5th score too soon, and we cannot. It gives us an error, right? And it tells us which level. Then we set the second score. You can see it appears. Trying to set the third score. When the second is too low, it just doesn't work. So it tells you can't set it for level 2. Of course, level 2 is position 3, so it's 0, 1, 2. Then we go ahead and we set levels, the second, third, fourth, and fifth scores. Some of these reach the threshold, some of them not. And then we try to set an 11th score, and it doesn't work. And really what you should do if you want to really test this, right, is keep trying different values and ideally try to populate the whole array. I mean, that's going to take a lot of stuff to do it, but this is proof right here that my error catching is kicking in and not letting me set a score for subsequent levels until the right score has been set for the previous. And that's kind of the intent here. Now, in terms of testing the other part of this, now what I'm going to do is I'm going to take my console, I'm just going to collapse it off to the side here. We can leave all that code in place, by the way. And what I'm going to do here is I'm actually going to put in comment mark just to kind of separate things out. So when I do the premium player will be down here. Was there an additional question? I just had a question as we were pausing to look at people's success or failure or whatever. How do all the scores get set to 0? And the answer to that really lies inside the class files, because we in both of these in the constructors, we come in here and we basically set and we create the array. And okay, so now Steve, I'm seeing kind of the nature of your question and why it works, right?
Exactly.
Right. So what we're doing here is we are creating new arrays that are integers with a preset number of positions. So we're, basically what's happening is the index number is acting as the level number, and then the array box that's holding the value is our variable. But your question is, how does it become a 0, right?
Right. I may be getting confused with the whole null thing with strings and all that.
Yeah, and that's basically what's going on here. It's auto generating the 0 by virtue of the way that we're instantiating it.
Okay, that would have made mine a lot simpler because I made it do that manually and didn't have to.
Yeah, right. And you know what? Yeah, see that's kind of like right. It's a programming experience thing, but there's nothing wrong with how you did it. If you did it manually, so there's like different schools of thought. Sometimes people kind of let go of the reins and let the automatic tools just do the work. And then in other cases, and you know what? I'm not sharing my screen right now, I'm realizing. And then in other cases, what happens is people will go in there and preset it,
Right.
and maybe even run a loop here or something to populate all the values, or make everything set to 0.
Yeah, that's what I did there.
Yeah, but it did happen automatically, and it basically just cast it in based on the fact that we created it the way that we did. But right. All right, so we're trying to teach all these different concepts all in one spot and all really quickly, and sometimes we skip over little pieces like that because we're focusing on a different concept. But yeah, there are some of those things that happen automatically like that have kind of happened over the evolution of a language. But I do know that a lot of programmers, and I kind of tend to be one of those people myself, is sometimes I just kind of manually do it because I want to make sure it's done and it's done a certain way and the values are a certain way. And it might extend a little bit from maybe being kind of a control freak or whatever. And if you're not taught that it does this, how would you know? So you do it manually. So absolutely. So that's a good question. Thank you for asking it. All right, so let's carry on, folks, now, and let's do the code now to do the premium player. Once again, I'm going to jump back over to code share, and I am going to drop that stuff in right here, and I am going to put in a divider just like I did on my other code, just so we can see where the premium player starts and ends and all that. All right, so with the premium player, same technique. We're first going to begin by instantiating the player, setting the person's name and ID, and then displaying their current status right at the start. I'm going to do all those lines at once, and they look like this. So we create the player. Yeah, you know, I want you to notice there's a little bit of a prefix difference here. Setting an ID number, setting a name, and then giving the information, and then it will run the display method and show us all zeros again. All right. And then, of course, we can test all the same types of parameters. And what I'm going to do here, folks, is I'm going to go through and drop in a few of them to test. And you'll see from the system out messages that follow each one of these what the intent of each one is. So first, we set the score for the first position. That's what happens here. So then we display it. Then we try to set a score too soon. After setting a second score, so we try to do that correctly and then show it. Try to set it too soon, and then take a look. Just trying all those different approaches. And then really, the fun part comes here where we can do something a little bit more sophisticated. And that is, what if we write a loop that just automatically sets all the scores for us and makes them right all the way through the 10 positions, so we're ready to move on to the premium levels, and let's just do that in the loop. So here's a little loop that will do exactly that and then display the results. So right here, what I'm adding will loop through, populate the first 10 positions with scores that are adequate to move on to the next, and then display it. Finally, we'll attempt to set the 11th position and see what happens and take a look, because that one should work because we have 10 already in place. And then try to set something that's out of range, like beyond the end of the array. So we're trying to set it for position 51 and see what happens. And would it work or would it not? All right, so let's see what happens with all of this. So feel free to copy all of this. I'm going to copy it all and bring it over to Eclipse. And you can just add that in. But it's really hard to copy when everybody's copying at the same time, right? You don't know where your highlight ends and the other person's begins. Just be careful with those curly brackets and stuff. All right, so I'm going back now to my demo program, and I will paste in right here. Fix the one indent that's a little problematic. I don't see any code highlighting, so it looks like my code is good. Should be, a copy pasted it, right? And now we're going to go ahead and run this with all the different scenarios. And it's kind of neat when you have it side by side like this. And if you're strategic about it, you can kind of see all your logic. And right now, I'm really going to be focused on more like the second set of logic, right? And so the first player was Alex. We're going to be looking at Corey. We know Alex worked just fine. So we're going to save this code. We are now going to run this code and take a look at the output. And you can see all the Alex stuff is still the same, but now we have a bunch of entries for Corey. And we start out once again by presetting everything to 0, just a name and an ID. We set a first score, try to set a fifth score too soon, no results. Set a second score, not good enough to get to the third. We can't set the third yet. It's not good enough. And it's proof it doesn't get in there. Then we try to set the second through the 10th scores by running a loop, and that works just fine. So everything reached the level that it should have. Then trying to set the 11th score, and did that work? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Where's the 11th score? We're not outputting the 11th value, are we? Right, so we have to adjust our loops. And so I think that part of our code is failing here. However, we could not set a 51st score because it's not valid. But I think the only little glitch that we have now is getting all the scores to display beyond the 10th position. Does anybody have an idea about how we might fix that? Where would we go to fix that piece?
Is that line 51? No, that's the setting it. That's not the,
Right.
yeah.
My guess would be on that 65 where it says get levels on line 65, because I think it's still pulling from the Sugar Smash player, not the premium Sugar Smash player. So it's pulling that 10 from the Sugar Smash player constructor instead of the 50 from the premium.
Right. And unfortunately, I didn't intelligently write my code here where it would dynamically adjust to either. But at this point, I think if we run this version of it, oh, but it doesn't have that, right? And so this is why, although it should overwrite that, right? No, that
Do you
should,
have to do like the @override above the private int levels?
yeah, maybe, Larry, that's really a good point. Let's try it here. Still not liking that though. Yeah, I am taking a look at my solution right now, so just bear with me here, folks.